Hello everyone, welcome to Biot-Savart Law and its applications. Now first, what is Biot-Savart Law? Well, it is a law that gives a quantitative measurement of magnetic field due to a current element. Now again, what is a current element? Well, here if you see this figure, you have this shape right here which is difficult to calculate the magnetic field for, and here current is passed through it. So what we do is we take a very small length which is known, this dl is known as the length element which is in the direction of the current, and then the current passes through that length element, and the product of, well, the current and length element together is known as current element. And of course, due to this current element, we will have a very small magnetic field, and in which we will integrate both sides to get the total magnetic field. And here, for Biot-Savart law, it has been found that the small magnetic field is directly proportional to the current element. If you want to stretch this out, you can say it is directly proportional to the current and directly proportional to the length element. But for here, we're talking about current element, so it's directly proportional to the current element. And it is inversely proportional to the square of the radius to the point and the current element. So if you're supposed to find the magnetic field at point P, then it is inverse proportional to the square of this, and it is directly proportional to the sine angle between dl and radius. So in this figure, dl is this going here and radius is this, and that is the angle between them, and combining together we get idl sine theta by r square. And here we have a constant, of course, and for that constant we have mu naught by 4 pi idl sine theta by r square. If you remember in electrostatic in chapter 11, class 11, you will find 1 by 4 pi epsilon for, well, electric field, and this is for magnetic field, so it is kind of similar. And this epsilon naught for electrostatics, well, instead of having it at the bottom, we have it at the top, and this was known as permittivity of free space. And here, similar to this, it is known as permeability of free space. Now, we have to use this for this first application right here, which is to find the magnetic field at center of a circular coil. Now, we have a current element right here. In fact, you can choose a current element anywhere, but the radius would be the same and the current element would be the same. Let's take it right here, and we have current element right here. Of course, the length element we have, and the current passes through it. Now, according to Biot-Savart law, we have I mu naught by 4 pi I dl sine theta by r square. Now, what is sine theta? Well, it is the angle between the current element and the radius. But here, if you, well, from math and from geometry, we know that this length element or current element is tangential to the circumference of the circular coil, meaning that their angle will be 90 degrees, which means that sine 90 is just 1, hence we will get mu naught by 4 pi I dl by r square. Now all we need to do is integrate both sides. So we integrate this and we integrate that. But of course we need a definite integral to find certain value, and for this one, the magnetic field, well, it goes from 0 to the radius. It goes from 0 to 2 pi r, the whole circumference, right? Because the current initially starts out at 0 and then eventually covers the whole circumference, which is 2 pi r. So this will be magnetic field. These I will take the constants outside, which is mu naught, 4 pi, the current and the radius square, and we will simply get 2 pi r dl, which is just 2 pi r, because you will get length from here and length, and if you plug this upper limit and lower limit, it becomes 2 pi r minus 0, which is just 2 pi r. So you can cancel pi r, r2, 2, 2. Therefore the magnetic field will become mu naught I by 2r. And let's just say this circular coil has n number of turns, then the magnetic field becomes mu naught Ni by 2r. This is for the center of a circular coil. This is the first application, and there are 3 more applications left. Or sorry, 2 more applications left. No, 3. So if you have learned something new, please like and subscribe. Thank you.